Hi, I'm going to continue with this topic of function inverses, and now I'm going to introduce some other concepts here in order to expand the possibilities of the process to get the inverse of a function. Now I have here two functions. The first one called f of x is equal to 3 times x plus 2 and g of x equal to x squared plus 2. And here I have on the left here I have a couple of sets here, x and y, and here as well I have a couple of sets x and y, and inside the sets I have just three values, and in this case here, and 3 and 2 below. And I'm just doing this in order to represent the possible inputs you could have for a function here, in this case for f of x, and here below for g of x. Now here on orange I have the evaluations of these functions for these values for x in both cases. Now I want to notice something here. I have here the values of f of -1, and the result is -1 here. And that is implying that if I get here from the value -1, applying the f of x, I will get to here by applying the evaluation of -1 in this function here. Now I have here 0 and 1, and I get these results, and I get that applying as an input to 0, I get from here to here. Applying the 1, I get from here to here. I get as an output the number 5 in this last case. Now I have here as well the same values evaluated for g of x. G of x is a quadratic function. It's x squared plus 2. Now let's see, it changed a bit. With let's start with the 0 first. G of 0, that the result will be number 2 here. That's saying that I get from here to here. But here comes the funny part. When I start with evaluating -1, I get as a result the number 3. That is to say, I get from here to here. But with 1, I get a result as well, number 3 here. So that is to say, I will get from here to here. And here comes the thing. The first function we have here, the f of x, it's something we call in mathematics a 1-to-1 function. I think just the name speaks by itself. You get a correspondence of 1-to-1 from each set of to the other one. From x to y, there's always a correspondence of 1-to-1. But this one here below, it's something called a many-to-1 function. And here, this case presents a problem here, because if we want to apply the inverse of a function in this first case, I would get with the inverse of a function, just as we saw before with the example Celsius and Fahrenheit degrees, I would get back, I will start from here and get to here, and then with the inverse function, I will get back to here. In every case, we get back like this. But here, there's something different with this other function here. If I try to get for number 2, getting back to where we started, I would get from here to here. But what happens with the number 3 here? There are two possible outputs here, and that is not possible. That is not a function. And we could not work this out with the inverse of this g of x. I'm going to show you something, how to identify these cases with something called in mathematics the horizontal line test. Here's the thing. I'm going to use decimals here on the right just to show you this. I already have these functions here in my decimals. So first, this is the function for f of x equal to 3 times x plus 2. It's a straight line. So this is, I'm going to draw here a horizontal line with this other function. And now notice something. If I draw this horizontal line all along all the possible values of this function, there's no way I can touch more than one point here. There's always a one-to-one connection, to say in a way. You cannot touch more than 1 point. But what happens here, with this x squared plus 2, I'm going to write this here first. I'm going to take away the y and here, just to show you the other function, this x squared plus 2. Now here, you can see it's a quadratic function here. And what would happen if I would draw this horizontal line here? I'm going to draw it now. Let's see. You can see that if you draw a lot of horizontal lines, except for the vertex, you will always touch more than 1 point. In this case, 2 points of this function here. Always touching 2 points, except for the vertex, but that's just a special case. The thing is the horizontal line, as long as you can find one situation, if you can touch more than 1 point, then this is telling us that this function is failing the horizontal line test, and we cannot get the inverse of this function just like that. So in order to get along and to find a way to find the inverse of this function g of x, we have to add something called a restriction. So I'm going to write it here in my decimals here. This is I'm saying here that I'm restricting the values that you can input to this function only for the cases of x greater or equal than 0. And you notice here that the values, now the function was a section here. We cut it by half here. And by doing so, now if we draw this horizontal line all along the function, we are only touching 1 point. No matter where we are in the domain of this function, we only touch 1 point here. And that is, now we successfully took the horizontal line test. I'm going to write this, it's called a restriction. I'm going to write it in here. Here, I'm going to write it. It's written like this, comma, x greater or equal than 0, just like the decimals here. And once we add this restriction here, we can now proceed to get the inverse of this function. This changed a bit the process we saw before. It's nothing serious, but this is just the introduction for this part of the course. So hopefully it was useful. Okay, let's move forward.